Two blocks P and Q of mass 10 kg and 90 kg respectively are connected by a light inextensible rope. The rope passes over a smooth pulley fixed to the apex of the wedge as shown in the diagram. P rests on a rough plane inclined at an angle of 30 degrees to the horizontal, and Q rests on a different rough plane inclined at 15 degrees to the horizontal. The coefficient of blocks P and Q and their respective planes are 0.5 and 0.05 respectively. The system is released from rest and Q accelerates down the slope. Calculate the acceleration and the tension in the rope. If P is 40 meters from the pulley, calculate the speed when P reaches the pulley. So if we draw a diagram, we'll draw the force diagram first. So we have the weight acting down on this one. We're just going to consider P first of all, which is 10G. We have the normal reaction, which we're going to call RP. As it's moving this way, the friction will act downwards, mu P RP. And we have a tension in the rope. And we have an acceleration going upwards. So for block P, resolving this way, perpendicular to the plane, we have RP, and then if we have, I can draw this line down here, this is 30 degrees, then this force here will be 10G cos 30, so minus 10G cos 30 is equal to 0 because it's moving no way that way, which gives that RP is 10G cos 30. Now if we resolve along the plane, so going this way we have T, minus this bit here, which is going to be 10G sine 30, it's opposite the angle, 10G sine 30, minus mu r, so mu p is going to be 0.5, so this is 0.5 times r, which is 10G cos 30, comes from that, and that's going to be equal to the mass times the acceleration using Newton's second law, 10 times the acceleration. We'll call that equation 1. Right, if we now consider the other block, which has got a weight of 90G acting downwards, its normal reaction acting upwards there, RQ, it's going to have tension going in the string, which is the same as this tension here. And as it's moving this way, the friction now acts up the slope, so we'll call that one mu Q RQ. And A acting that way. So for the block Q, again, resolving this way, perpendicular, we're going to have the RQ minus this force here, which is going to be 90G cos of 15, is equal to 0. And then RG will be 90G cos 15. And then resolving along the plane, so going this way, so there's no actually force except the weight, this component of the weight here. So this component of the weight here will make it go downwards, so it's going to be 90G sine 15. And then going in the opposite direction, we're going to have the tension and the friction, which is going to be 0.05 times my value of RQ, which is 90G cos 15, and that's equal to the mass, which is 90 times acceleration. We'll call that equation 2. Right, we've got two unknowns, T and A, so to eliminate them, we're just going to do 1 plus 2, and so we're going to be very careful here. So we're going to have 90G sine 15, and then T minus T will cancel out, then we've got minus 10G sine 30, and then we've got 0.5 minus 0.5 times 10, which is 5, so we've got minus 5G cos 30, and then we've got here also minus 0.5 times 90G, which is going to be 4.5G, and don't forget the cos 15, and then 10A plus 90A is going to be 100A. So writing that out again, all right, so to make A the subject, we need to take all of this and then divide it by 100. So on our calculator, using the fraction button, carefully making sure our calculator is in degrees, and don't forget to put in any of the G's, that will give you 0.94245. So to three significant figures, that will be 0.942 meters per second squared. But put this one in the memory of a calculator because we're going to be using it again. Right, in order to find the tension, so substitute into equation 1, which is this one here, T minus 10G sine 30, 0.5 times 10G cos 30 is equal to 10A. So you're going to have T is equal to 10 times 0.94245 plus 10G sine 30 plus 5, so half of 10, 5G cos 30, which is going to give you 100.85, which will give you 101 newtons. Right, now to, we're told that this is 40 meters away when it starts. So A is going to be my value I've already calculated, 0.942, and the initial speed is 0. So using v squared is equal to u squared plus 2as, we can have that v squared is equal to 0 plus 2 times 0.9424 times my distance, which is going to be 40. And then on my calculator, that will give me 75.395. That gives me v squared. So to get v, you need to take the square root, which is 8.683, which gives a final speed of, when it reaches the pulley, of 8.68 meters per second. So this has been a video of connected objects and finding the speed that one object hits the pulley, or when it reaches the pulley. I hope you've understood, and I thank you very much for watching.